All right, in this lesson, we're going to talk about domain and range. So focus for learning for the lesson is, I can identify the domain and range of a function given a graph, table, mapping, or set of ordered pairs. So we're finding the domain and range of functions given multiple representations. So first we need to go over some vocabulary words. So the domain of a function is a set of all of the possible inputs for that function, or all of the possible x values. The range of a function is the set of all the possible outputs, or all of the possible y values for that particular function. So domain is all of the inputs, it's all of your x values. Range is all of the outputs, all of the y values. Some more vocabulary here, a continuous function. So if a graph is continuous, it is a graph where all of the points are connected by a line or a curve. Then another important vocabulary word here is discrete. So if a graph is discrete, that means the points are not connected. And we're going to look at different examples of continuous and discrete. And it's actually going to change how we write the domain and range based on whether the graph we're looking at is continuous or discrete. So first we're going to start by looking at functions that are discrete. So when your graph is discrete, you write the domain and range as lists. So we're going to look at an example here. So the first example on your paper, you just have points on a coordinate plane. So the very first thing that you would do is you would want to go through for each point and you want to list the coordinates of each point. This will help us when we're trying to identify the domain and the range. So you want to go through on your paper for each point, you want to write the coordinates, the ordered pairs of each point. Now we know that this graph is discrete because from our definition of discrete, it said the points are not connected. And we have all of our points on a graph here and they are not connected. So if we want to write our domain and our range, we're going to write each of those as lists. So remember, the domain is all of your possible inputs. It's all of your possible x values. So you want to put your list in a set of brackets like I have here, like the curly braces. And then you're going to go through and you're going to list each x value. So we can see if I move my box away here. Oh no, I accidentally made a couple more. If I look at this point, my x value is -6, so I put that in my list for domain. Here, -2, 5, my x value is -2, so that goes in my list for domain. 0, 7, my x value is 0, so that goes in my list for the domain. -5, 0, my x value, remember it's the first coordinate in your ordered pair, is -5, so that goes in my list for my domain. And then down here, -2, 3, for this point, my x value is -2. That's already in my list though, so I don't need to write it again. So if any x values show up in multiple places, you only need to put them one time in your list. Now for the range, remember range is all the possible y values. We're still on a discrete graph, so we're still just going to make a list, but you're going to go through each ordered pair and you're going to put the y value in your list. So you see here, each point has a different y value, so we just go through. We take the y value from each ordered pair and we put them in our list because the range is all of the possible outputs or all of the possible y values for a function. All right, number 7, we just have a set of ordered pairs. This is also an example of a discrete function. These points here, they are just points, they are not connected. So remember when you have an ordered pair, the first number is your x coordinate, the second value in parentheses is your y coordinate. So domain is all of your possible inputs, all of your possible x values. In this example, we only have one input. Even though we have 3 ordered pairs, they all have an x value of 0. So the only value in our domain is 0. It's the only possible input for this function, or for this relation. The range is all of the possible y values. So here, our possible y values are 4, 6, and 8. So if we think back to what we learned before about whether or not this is a function, we can actually say this is not a function because the input of 0 has multiple different outputs. It's still a relation though, and we can find the domain and range of it. All right, this next one we're going to look at a table. So when you're looking for the domain from a table, this is discrete. So we're just going to list all of our x values in a list. So again, in brackets, we're going to go through and you list all your x values. So -2, -5, -9, 6. Those are all of the possible inputs here. So those are all of the values in the domain. For the range, remember range are all of your possible outputs or all of your y values. So we're going to go through and we're going to list all of the possible outputs, all of the y values from the table. So here we have -1, then our next output is -8, and then -8 shows up again, but you only put it once in your list. There's no need to put it twice. We already have it as a value for the range. And then our last output is 10. So even though we have 4 entries in this table, there are only 3 possible outputs. So there are only 3 numbers in our list for the range. All right, so those were all those were all discrete graphs, which means the points were not connected, and we just put the domain and range, we wrote them as a list. When your graph is continuous, which from our vocabulary at the beginning, it means the points are connected by a line or a curve, you write the domain and range using inequality notation. So if we look at this circle here, we know a circle is not a function because it does not pass the vertical line test. However, we can still write the domain and the range of this graph. So the domain is all of your possible x values. So we want to look at our circle and we want to find the smallest x value and the biggest x value. So if we look here, it looks like our smallest x value is -8 and our biggest x value is 2. So when we write the domain of this graph, we're going to say that -8 is less than or equal to x, because domain is all of our x values, is less than or equal to 2, because that's our biggest x value for the domain. So essentially what this is saying is all of the x values for this graph are in between -8 and 2. For the range, we're going to look at the y values or the outputs, and we're going to do the same thing. So we want to find our smallest y value, which is -6, and we want to find our biggest y value, which is 5. When we write the range, your smallest y value comes first. So we're going to say -6 is less than or equal to y, because y is the value for the range. Range is outputs. Less than or equal to 5. So this is saying that all of the possible outputs for this graph are between -6 and 5. So all of the numbers that are between -6 and 5 are possible outputs for this graph. Now from the video you watched on inequalities, for both of these we put the less than or equal to because -8 and 2 are included as values for the domain. -8 is an input and 2 is an input. Same here, we put the less than or equal to symbols in the range because -6 and 5 are included values in the range. So this is saying all the possible inputs for our graph are between -8 and 2. All of the possible output values for the graph of the circle are between -6 and 5. All right, here we have another continuous graph because the points on it are connected by a curve. So when we're looking for domain, we're looking at the x values. So you want to look at your graph. You want to find the smallest x value, or the one that's furthest to the left, which would be here. And you want to find the biggest x value, or the x values that's part of the graph, or the one that's furthest to the right, which would be right here. And then we're going to take those and we're going to put them in inequality notation. So we're talking about domain, which means we're talking about the x values. So we know we're going to have the x in the middle there. Our smallest x value is -7. So we're going to say -7 is less than, because this is an open circle on the graph. So that means -7 is not included. It's not an input for the graph. So we're just going to say it's less than x is less than or equal to +7. Here we have a less than or equal to because our endpoint on positive 7 is filled in, which means positive 7 is a possible input for this graph. It is a part of the domain. All right, when we're doing the range, we want to look at our y values. We want to find our smallest y value, which looks to be negative 7, and our biggest y value, which looks to be 8. Now, both of those points are on the curve, which means they are included in the range. So when we go to write this in inequality notation, we're going to say negative 7 is less than or equal to y, because we're talking about the range, is less than or equal to 8. So all of the outputs, or all of the possible y values for this graph, fall between negative 7 and 8. All right, here we have a line. So again, this is a continuous graph. It's a line. It goes on forever in both directions, as shown as the arrows on the end. So for our domain, we want to think, if this line keeps going forever and ever and ever and ever and ever and ever in the positive x direction, and it keeps going forever and ever and ever and ever and ever in the direction of these negative x values, that means every single real number is going to be an input for the line, or every single real number is a possibility or is a part of the domain. So here we want to say the domain is all real numbers. And this right here, the R with kind of the two legs on it, that's how we put all real numbers in symbol. So it's saying any real number is a possible input. It is part of the domain. Same thing if you think about the range. My line's going to keep going forever and ever and ever and ever and ever in the positive y direction, and it's going to keep going forever and ever and ever and ever and ever in the negative y direction. So the range of this function is also all real numbers. Any y value will work.